Beginning of chapter 3, beginning of the pre-calculus. The pre-calculus is the study of functions, okay? So what are functions? Well, functions are defined, okay, as a rule assigning all values from one set to one and only one value of another set, okay? You should have been familiar with that from algebra. And that definition is going to become a little bit more familiar to you once we start looking at some examples. Domain is the input values, generally the x values, okay, generally what we call the independent variable. The range is the output values, generally the y values, generally called the dependent variable, okay? The functions have a very simple test to see whether it's a function or not. It's called a vertical line test. Quite simply, vertical line intersects more than one point on a graph. That graph is not the graph of a function. Okay? Functions are recognized because they can be written explicitly y in terms of x. Explicitly y in terms of x. So here you go. I mean, an equation of a line as represented here is not explicitly written y in terms of x as 2x minus 4y equals 12. It is written as an explicit, an implicit function rather. When it can be written solving it for y, which is when we're changing it from standard form to a slope-intercept form, then we are writing it, okay, explicitly y in terms of x. Explicitly y in terms of x, okay? And in fact, when it is written y in terms of x, that is y isolated by itself, it can in fact be typed into our calculator, and it is in fact a function. And since it is a function, we need to show it a little respect. So we have a new notation, simply the f of x notation. It has risen to the ranks of a function. So give it some respect and call it a function, okay? So is a circle a function, okay? Is a circle x squared plus y squared equals 25 a function? Well, we know the graph of that, okay? You say, where's the rest of the circle? It's there, just didn't show up. Got lost somewhere, okay? But is this a function? No. Doesn't pass the vertical line test, okay? It does not pass the vertical line test. Oh, however, I can solve this y in terms of x as shown here. I can isolate y, and if I can isolate y, I can turn it in. I can ask my calculator to graph it. And if I can ask my calculator to graph it, then it must be a function. Well, guess what? We lost something. We lost something when we when we turn this into a function. And we can call it a function. But guess what the picture is? Half a circle. Half a circle, excuse me, because it must pass the vertical line test. It must pass the vertical line test. So you say, where's the other half of the circle? Well, if you key in to y2, the opposite, put the negative sign out in front of that, you will see the bottom half of that circle. So the circle is functionalized, but in functionalizing it, we lost something, okay? And that's our function, okay? When we can write something, y in terms of x, okay, then it is a function. And the values going in, the x values, okay, comprise what we call the domain. The y values comprise what we call the range. So let's talk about some familiar functions. Things I call the 7 deadly functions. Yes, the 7 deadly functions. Quite innocent, mind you. There's the absolute value we all know and love, the absolute value of x, okay? All right, so we ask a couple questions about each graph. What is its domain? What can we put in? Anything at all. Anything and everything will go in, okay? Positives as well as negatives, okay? It lives for all values of x. So therefore the domain is wide open, okay? Negative infinity to positive infinity for x, okay? What is the range, the output, the y values? Strictly positive, okay? So the range is from 0 to infinity, okay? From 0 to infinity. That's the y values. What is the symmetry? The symmetry, well, it looks like it's a mirror image across the y-axis. So it has y-axis symmetry. It is what I have called a stupid function. A stupid function indeed, because it doesn't know the difference between a positive and a negative x. It does not know the difference between a positive and negative x. Give it a 3, it gives you back 3. Give you a negative 3, it gives you the same thing. So the function, like another function here, which is another equally stupid function, x squared, excuse me, give it some respect, a function f of x equals x squared, whose domain is every conceivable value, no values that cannot go in for x, therefore the domain is everything in the world, right? Okay, the range only gives us back positives. It only spits back positives, so the range, just like absolute value, is the same, only positive values. And again, it doesn't know the difference between 3 and negative 3. It's stupid. It's symmetric, okay, about the y-axis, okay? Would we ever have to worry about symmetry about the x-axis? No, because then it wouldn't be a function, would it? Because it would fail the vertical line test. Okay, let's see what's up next. Our good friend f of x equals x cubed. F of x equals x cubed. What can we put in for x? Every value in the world, no restrictions. What comes out? Every value in the world, no restriction. It takes on all x's and it gives back all y's. What kind of symmetry does it have? It's a reflection across the origin, around the origin. Okay, so it's symmetric about the origin. How do you tell origin symmetry? Put in opposite values of x, it results in opposite values of y. Put in 2, it gives you 8. Put in negative 2, come back. Put in negative 2, it gives you negative 8. That's how we check for symmetry about the origin, okay? Our good friend, the square root of x, okay, which is one now which has some restrictions in both the domain and the range. The domain, you can't take the square root of a negative. We've known that. You've known that since day one. Okay? It lives in an imaginary world. Therefore, the domain is restricted. Restricted how? Restricted to simple positive numbers, right? 0 to infinity. Okay? What about the range? Likewise. Now you say, oh, I thought the square root of something went both positive and negative. If the square root of x resulted in both positive and negative, then we would have a mirror image across the x-axis down here of this, and it would be a flagrant violation of the vertical line test. And therefore, when we don't have a sign for the root, we understand it to imply only the positive. Okay, there is no symmetry with this guy. Okay, here is a semicircle. It is called the unit circle. It is the circle, okay, of radius 1 centered at the origin. There it is, okay? It is lives in a very small world, doesn't it? It lives in a very small world. Its domain can only run from negative 1 to positive 1, okay? And its range will only run from 0 to 1. And as you can see, it does possess symmetry, okay? It is another stupid function because the x squared is in there, and it will not know the difference between a negative x and a positive x. And you'll say, well, what if I put in, okay, what if I put in x equals 4? Yeah, go ahead, put it in. What happens? You get 1 minus 16, the square root of the square root of negative 15. That doesn't exist, right? Well, it's not supposed to because that's outside of the domain of our function, okay? Here's our good friend who is not defined at 0. It is not defined at 0. What is its name? The function f of x equaling 1 over x, okay? The function where we get an undefined value at x equals 0 because division by 0 is undefined, okay? And this is why I've always told you, tell me what it can't be. Tell me what it can't be, because the implications here graphically are that it can't equal 0, and that imposes this what we call this asymptote right here, okay? So that is a restriction in the domain, okay? So the domain cannot equal 0, but to say what it is, to say it cannot equal 0 is to say what it is not. To say what it is to have to be listed in this sense, from negative infinity to 0, in union with 0 to infinity. Why is the range the same? Why is the range the same as the domain? Okay, it is. Why? Because the asymptote is not only the x-axis, it is also the y-axis. What, you say? Just try it. Put in x equals 100. You get 1 over 100. Put in x equals a 1,000. You get 1 over 1,000. The further you go out the x-axis, the closer you get to it, but you never reach it. It's an asymptote. Therefore, the range is the same as the domain. Okay? And the last of our seven deadly functions, a function which, again, lives wide open from negative to positive infinity for both its domain and its range, which has symmetry about the origin because when you give it opposite x's, it gives you opposite y's. When I give it 8, it gives me 2. When I give it negative 8, it gives me negative 2. It is symmetric about the origin, therefore, okay? Because opposite values of x result in opposite values of y, okay? It has an unlimited domain and an unlimited range. What is it? What is it, you say? None other than the cube root of x. Don't look for this symbol on your calculator. You need to enter it as x to the 1/3 power. X to the 1/3 power, okay? So that is our cube root of x. That is our cube root of x. Now, what happens when we take bits and pieces of these seven deadly functions? When we take bits and pieces of these seven deadly functions, we comprise what we call piecewise graphs. Okay, here it is, a piece of 1 over x, then a pickup of the square root of x right there. Okay, what is this alien form, you say? Well, here it is. It's the absolute value of x, but with restrictions on it. Okay, and a unit circle. Now we'll have a lot of fun with these coming up real soon. Okay, but don't forget your seven deadly functions, their domain, their range, their symmetry, okay? And we will have some exercises for you, okay? Watch it again and again, enjoy it, make sure you understand your introduction to functions.